All right, let's start that from the beginning. Hello, everyone. Um, Rizel, I see you in chat. Hello, hello. Thank you for the follow. So okay, let's try that again. Today is an exciting day because I am starting a brand new series on Dart. So it's gonna be cool because we're gonna be building the same app. We're gonna be building the same app in Flutter. The one that we built previously in SwiftUI. Hold on, just let me try something. Okay, there we go. There we go. Yeah, so we're gonna be building the same app in Flutter, and because I'm a total Dart noob, we're gonna start with Dart, the language itself. We're gonna explore Dart, see what is it about, and yeah, basically that's the idea behind this stream. So we're gonna start. Oh man, my audio is acting up like crazy. Let me know if you can't hear anything or if it's terrible to listen to. Awesome. Thanks, Reese. Yeah. So I guess we can begin. There we go. I have right here opened the tour of the Dart language. So we're gonna read through the documentation, get acquainted with the language, maybe try solve some programming problems with Dart just to get the hang of it. And if we feel like it, we could totally get into Flutter. If not, then it's gonna be next Tuesday. But yeah. So Dart, as I learned, Dart is a programming language made by Google. And there we go. Paint your UI to life. It is like a UI language. It's a client optimized language for fast apps on any platforms. Optimized for UI. So, develop with a programming language specialized around the needs of user interface creation. That's awesome. And yeah, Flutter uses it to build mobile apps and even web and desktop apps. You can basically, if you use Flutter, you can basically do everything. And we're gonna check it out. So target the web with complete, mature, fast compilers for JavaScript. Awesome. So for example, if you're building a web project in Dart, first it compiles to JavaScript. Compile.js. There we go. But we're not gonna do that now. We're gonna focus on mobile. We're gonna focus on mobile and see what it is about. I was like going through the developer survey, the one from Stack Overflow, and I saw that Dart is pretty much one of the most loved frameworks. And that intrigued me. I was like, okay, if the majority of the people prefer Dart and Flutter, then I need to check it out. There's definitely something worth checking out. It was like even more loved and maybe even like more used than React Native, because I was also checking out the trends.google.com website to just see and compare like the number of searches for Dart and for React Native. And it turns out, sorry, I keep saying Dart, but I actually mean Flutter. Because I can't compare a mobile framework with a programming language. It's like apples and bananas. But yeah, it turns out that Flutter is more searched for on Google than React Native. And I didn't know that. I always thought that React Native is like one of the top, most used cross-platform frameworks. But it's been a while since I was in mobile, and things change. So now, apparently, Flutter is the king, and we're gonna get into it. All right, so how I imagine this episode is gonna go is we're gonna learn just pure Dart, no frameworks, no UIs, just the basics. And I thought, we can go through the tour of the Dart language website. I also have, as you can see, I also have a Dart pad right here open where we can try out some of the stuff. If we feel chill enough, like brave, sorry, not chill, brave enough, we could even go on, I don't know, some of these websites, like what was the hacker rank, yeah, hacker rank and things like that, and actually take Dart for a spin. We're not gonna be submitting anything, just try to solve something using Dart, right? Let's check it out. So I'm gonna be reading out loud and we're gonna be checking out some examples. This page shows you how to use each major Dart feature, from variables and operators to classes and libraries, with the assumption that you already know how to program in another language. For a briefer, less complete introduction to the language, see the language samples page. I guess we're just gonna go with this one. To learn more about Dart's core libraries, see the library tour. Whenever you want more details about a language, check out the actual language specification. Awesome. You can play with most of Dart's language features using Dart pad. And this is what we have open. This is the Dart pad, and I actually love this. It's super cool that you can try out features without spinning, local installations and VMs and whatnot. Awesome. Okay. A basic Dart program. The following code uses many of Dart's most basic features. There we go. You know what? I'm just going to zoom in a little bit so you can see better. So this is how we define a function. We set the return type of the function. In this case, it's a void. We get the name, type of the argument, and the argument name. Awesome. We have the curly brackets, and then we print the number is, and I can actually see there's a $sign, so this probably means it's like a interpolation. Is that the name, interpolation? Yeah, basically, yeah, get the actual value and print it here. And this prints to the console. Awesome. This is where the app starts executing. This is the main. It reminds me of Java, honestly. And there we go. We have the number 42, declare and initialize a variable, and we can call this function that prints out the number. All right, so let's actually check that out. We can do var number equals 42. The value of num isn't used. Okay, we will use it. And then we can print. Let's actually call it print number, and we'll pass num. We're going to declare a new void method or function, print number, and we're going to get that number as an argument, and we're just going to print the number. The number is $num. Let's see if it makes us. Yeah, there we go. Expected to find semicolon. Yeah, we need to provide that semicolons. Okay, we should see the number is 42. Nice. What if we actually... Oh, wait a minute. There's a documentation pane right here, and nice. It gives you a little preview. Awesome. Prints a string representation of the object to the console. All right, now this is cool. This is cool. Okay, what if we just... I don't know. What if we create something like... let's create a method that's going to return the number of... roughly the number of years you are today. So, how are we going to name this? let's name it how old. Okay, so we're going to get the year of birth, Yob, and we're going to return 2022 minus Yob. Okay, and now we're going to print Lazar is... Can I do this? How do I call this immediately inside. Or expression. Nice. So we can do expressions. Okay, let's do this and we're gonna get back to the document because I think we're like moving astray. How old? And I'm 1994. And let's see. Lazar is 28. That is correct. Okay, so this is cool. So far, so good. Here's what the program uses. Okay, this is a comment. Sweet. This is a special type that indicates a value has never been used. Sweet. Integer. I like this. Built-in type string, list, and bool. Oh, string is with a capital. Wait. What if we do string name equals Lazar? Is that gonna be... Yeah. Undefined class string. So string is with a capital. Man, this is very Java. Hold on, the music is killing me. Nice. Okay, cool. There's a number literal, the handy way to display output. This is a string literal, so single quotes or double quotes, it doesn't matter, just like in JavaScript. That's nice. Here's a variable name with a $sign. It's a string interpolation, including a variable or expression's string equivalent inside of a string literal. So this is an expression. That means we could probably do some math inside, or like some stuff. I don't know. Let's see. How old is Lazar? Lazar is 28. Okay, let's see minus 5, and let's see wishes he is. Okay. Let's see. This is basically, yeah, there we go. It's a string interpolation. So we're getting the value from how old, but then we can also do some math inside of these curly brackets or braces. What was the difference? Yeah, so if it's an expression that we can easily write something inside, and yeah, Lazar wishes he is 23, but he is not. Okay, so main, that is a special required top-level function where the app execution starts. We can check out more info on the main function. We're gonna skip it now because I don't feel like it. So, alright, so var is a way to declare a variable without specifying its type. Alright, so there, yeah, of course, I mean, we saw that there are types in Dart. It's a strongly typed language. Okay, so the type integer is determined by its initial value, 42. That means it's also, yeah, it can also infer the types based on the value, right? For example, we have number equals 42. We don't specify that it's a string or it's an array. If it's 42, then it's definitely a number. And if we click on it, yeah, the documentation will tell us that it's an integer, right? It's the number, it's an integer because we set it to 42. Cool. All right, so let's check this out. Important concepts. As you learn about the Dart language, keep these facts and concepts in mind. You know what? I'm just gonna get rid of this whole block, whole section right here because it's limiting our real estate. There we go, much better. So, keep these facts and concepts in mind. Everything you can place in a variable is an object, and every object is an instance of a class. Even numbers, functions, and null are objects, with the exception of null. If you enable sound null safety, all objects inherit from the object class. Okay, so everything is an object. That's good to know. Version null safety was introduced in Dart 2.12. Requires a language version of at least. Okay, we got that. Although Dart is a strongly typed, type annotations are optional because Dart can infer types. Yeah, we already got that. I need a new playlist. 8-bit sheriff. Alright, 8-bit sheriff it is. If you enable, where were we? Infer types, yeah.
In the code above, number is inferred to be of type integer. Yes, we actually saw that. If you enable null safety, variables can't contain null unless you say they can. You can make a variable nullable by putting a question mark at the end of its type. So just like in JavaScript, for example. A variable of type integer and then a question mark might be an integer or it might be null. If you know that an expression never evaluates to null, but Dart disagrees, you can add an exclamation mark, to assert that it isn't null and to throw an exception if it is. For example, nullable but not null integer, and then the exclamation mark. This is like Swift's force unwrapping, right? You can unwrap an optional value that can return null or the value itself, but if you put the exclamation mark, you basically are crashing your app if that is actually null. So it's a gamble. When you want to explicitly say that any type is allowed, use the type object and also a question mark, okay? If you've enabled null safety, objects without the question mark, or if you must defer type checking until runtime, the special type dynamic. Okay, so we also have dynamic in Dart. That's awesome. Dart supports generic types, like for example, lists of integers. That's cool, or a list of objects of any type. I really want to check out this object thingy because they claim it's a number. It can be a number, a string, it can be a boolean and everything. So let's actually see that. We're going to return an optional object, or like basically any. Let's name it gimme something. Okay. And in order to control that something, let's also get an integer of, I don't know, I. And for example, if I is less than 5, give me I. If I is greater than or equal to 5, and if I is less than 10, let's say, return okayish, for example. If I is greater than or equal to 10 and is less than 13, I don't know, return false. Otherwise, return null, okay? So what is this now? Let's see if Dart agrees with me. Oh, I forgot the I. Sorry, there we go. Nice. So I guess we can do a for loop right here. Initializers were like integer. Okay, I equals to 0. I believe this is the correct way. Let's go until 15. No issues. Okay. And now let's print whatever gimme something gives us. Let's see what we get. Gimme something. Do I have like a typo? There's no H. What about it? Okay. Alright, so this is actually pretty cool. First 5 values, 0 to 4. Then it's the okayish as a string. Then it's false for the between 10 and 13. And then we actually pass null. It really works, right? Awesome, awesome. Object is basically any. I'm gonna remember that. Alright, so Dart also supports top-level functions such as main, as well as functions tied to a class or object, static and instance methods respectively. You can also create functions within functions, nested or local functions. Sweet. Similarly, Dart supports top-level variables as well as variables tied to a class or object. Instance variables. Instance variables are something known as fields or properties. Okay? So if we made a class, I believe this is how you define a class. No, maybe without the equals. Yeah, there we go. What is that? Constructor? Is it constructor? We can do string name with a capital S. Non-nullable instance name must be initialized. Alright, so then no. There has to be a solution for this. Unlike Java, Dart doesn't have the key. My goodness. You know what? I'm gonna go back to my old playlist. This is just terrible. Pick one, pick two. Okay. Okay. Moving on. Unlike Java, Dart doesn't have the keywords public, protected, and private. If an identifier starts with an underscore, it's private to its library. For details, see libraries and visibility. Identifiers can start with a letter or underscore, followed by any combination of those characters plus digits as well. Dart has both expressions, which have runtime values, and statements, which don't have runtime values. The expression was this, if you remember. We had the curly braces inside. For example, the conditional expression, if the condition is true, then give me the expression 1, otherwise we'll return expression 2, has a value of either expression 1 or 2. Compare that to an if-else statement, which has no value. Okay, and a statement often contains one or more expressions, but an expression can't directly contain a statement. Okay. Of course, yeah, we can't put ifs inside of the... Okay, that's reasonable. Dart tools can report two kinds of problems, warnings and errors. Warnings are just indications that your code might not work, but they don't prevent your program from executing. Errors can be either compile time or runtime. A compile time error prevents the code from executing at all. A runtime error results in exception being raised while the code executes. Okay, we have a solution for that. Keywords, okay? These are the keywords that the Dart language treats specially, okay? Avoid using these words as identifiers, however, if necessary, the keywords marked with a superscript can be identifiers. Okay. What do we have? Deferred. Let's go. Now let's get into variables. Alright, here's an example of creating a variable and initializing it. Hello, Bob. Variables store references. The variable called name contains a reference to a string object with a value of Bob. Get the hell out of here. The type of the name variable is inferred to be string, but you can change that type by specifying it. If an object isn't restricted to a single type, specify the object type, or dynamic if necessary. Okay, we gotta see the dynamic thingy. So object name equals to Bob. We can also change the name to be a date or a number later on. Another option is to explicitly declare the type that would be inferred. String name equals Bob, okay? This page follows the style guide recommendation of using var rather than type annotations for local variables, okay? So use vars. Default value. Uninitialized variables that have a nullable type have an initial value of null, right? So if we, it's something like we did here. So name will be basically null because we don't have value. If you haven't opted into null safety, then every variable has a nullable type. Even variables with numeric types are initially null because numbers, like everything else in Dart, are objects, right? So an optional integer is null, it's not zero. Okay, the production code ignores the asserts. During development, on the other hand, assert condition throws an exception if condition is false. That's actually cool. If you enable null safety, then you must initialize the values of non-nullable variables before you use them, right? So if you enable null safety, you can't have optionals. And I think I'm like used to optionals. So we're not gonna be enabling the null safety. You don't have to initialize a local variable where it's declared, but you do need to assign a value before it's used. For example, the following code is valid because Dart can detect that line count is a non-null by the time it's passed to print. So this is where we declare it. It's either gonna go into the count lines or equals to 0. So by this time it will have a value, so it's not going to complain. It's actually called top level and class variables are lazily initialized. The initialization code runs the first time the variable is used. Okay, so that means we don't actually need to make this as an optional, but if for example we get a value here, right, and to, I don't know, this is it this, yeah it is, this dot name equals to name, then all of the errors will go away. No. Oh, check this out. Try adding an initializer expression or a generative constructor that initializes it, or mark it late. Okay, let's actually continue because this is interesting. You can mark it as a late. Is that like a late string? No. I wonder what this is. All right, let's go back and see. There we are actually, yeah. Late variables. In 2.12, Dart added the late modifier, which has two use cases. Declaring a non-nullable variable that's initialized after its declaration, or lazy loading or lazily initializing a variable, which is pretty much what we're doing here, right? If we mark the name as a late variable, we're basically initializing it lazily whenever we create an instance of the user class. Often Dart's control flow analysis can detect when a non-nullable variable is set to a non-null value before it's used, but sometimes analysis fails. Two common cases are top-level variables and instance variables. Dart often can determine whether they're set, so it doesn't even try. Okay. If you're sure that a variable is set before it's used, but Dart disagrees, you can fix the error by marking the variable as late. That's actually what we did here, right? So if, for example, if we don't have the late keyword here, and if we did, I don't know, say hello, or like let's call it greet, right? Greet is the name of the function. We can print hello name. So we cannot use greet before we actually initialize this class. But when we initialize this class, we're also gonna set the name. So name will always have a value at this point, right? Let's actually remove this equals, I guess it's new user dot greet. So first we're gonna get an error here, unnecessary new. Okay, so we don't have new, that's all right. Oh, check this out, that's why Dart complains, because even though I have a construct, is this the constructor? User dot construct? No way, that's actually not a constructor. Okay, we need to check out classes. Because that is not a constructor. Where are we right now? Variable. Sorry, let's jump to classes real quick and see. Constructor names can either be class name or class name.identifier. Okay, so how do I actually create a new class?
Maybe there is no... Oh, okay. Oh, it's the name of the class. It's the name of the class. Okay. Line 5. Use initializing formals when it's possible. 1 positional arguments expected, but 0 found. And that's this. Okay, so we can add the name right here. So this will, okay, it will go away. Non-nullable instance field name must be initialized. Try adding an initializer expression. And what is that? Yeah. Because a type that's potentially non-nullable, doesn't have an initializer, isn't marked as late. So do we need to... Oh, okay, got it. So instead of making this like so, is this the correct way? Actually, yeah. This is the constructor. This is the constructor. What if I wanted to like type this? Maybe Dart doesn't support that. You see that? That is how you create new actually constructors that take values and immediately assign them. Okay, this is pretty cool. When I do greet right now, it should say hello Lazar. And hello back Lazar. Okay. Alright, that's cool. That's cool. Let's go back to the variables where we were. There we go. There's the lazy variables. This is cool actually. Marking the declaration as a late to basically tell Dart, chill. I'm gonna assign a value. Don't worry. Nice. If you fail to initialize a late variable, a runtime error occurs when the variable is used. Okay. So we can do, I don't know, late string or like a late integer age. Hello name. Your age is age, but we're not actually initializing. We're marking it as a late. We're not initializing it. No errors. Let's actually see what happens. Runtime error. Late initialization error. Field age has not been initialized. Field age has not been initialized. Okay. Okay, that makes sense. Final and const. If you never intend to change a variable, use final or const. Either instead of a var or in addition to a type. A final variable can be set only once. A const variable is a compile time constant. Const variables are implicitly final. Okay. Instance variables can be final but not constant. Here's an example of creating and setting a final variable. Final name equals Bob without a type annotation. Final string nickname equals Bobby. Okay. You can't change the value of a final variable. If we try to change the name to Alice, we're gonna get an error. A final variable can only be set once. Use const for variables that you want to be compile time constants. Alright? If the const variable is at the class level, mark it static const. Where you declare the variable, set the value to a compile time constant, such as a number or string literal, a const variable, or the result of an arithmetic operation or constant numbers. So, a constant would be a huge number like this, units of pressure, or it can be standard atmosphere, right? Something like the multiplied by something else, and we put that as a constant. Okay. The const keyword isn't just for declaring constant variables. You can also use it to create constant values, as well as to declare constructors that create constant values. Any variable can have a constant value, okay? So, we have a variable called foo, which is declared to which is initialized to a constant empty array. And I guess this is like the same. These are all the same, right? So we can also do a final variable bar, which is a constant empty array, and also const buzz equals to an empty array, which is equivalent to const empty array. Okay. You can omit consts from the initializing expression of a const declaration, like buzz. For details, don't use const redundantly. I think we should check this out, because we're coming with a huge JavaScript bias, and I personally would const everything, so this is something that we need to definitely read. In contexts where an expression must be constant, the const keyword is implicit. It doesn't need to be written, and it shouldn't. Those. Hey, Will Johnson, thanks for the follow. Appreciate it. Yo. Right? The const keyword is implicit. It doesn't need to be written, and it shouldn't be written. This is interesting. Like, okay, these contexts are any exceptions inside a const collection ritual, a const constructor call, a metadata annotation. I don't know what this is. The initializer for a const variable declaration, a switch case expression, the part right after case before the colon, not the body of the case. Okay. Default values are not included in this list because future versions of Dart may support non-const default values. Basically, any place where it would be an error to write new instead of const, Dart 2 allows you to omit the consts. Yeah, this is good. Const primary colors equals, and then we have an array of colors, but we don't actually need to put constant to every value. Okay, that's okay. That was a good read. You can change the value of a non-final, non-const variable, even if it's used to have a const value. Foo equals. You can change the value of a const variable. Constant variables can be assigned. Can't be assigned a value. What is it? Wait a minute. You can change the value of a non-final, non-const. Okay, even if it's used to have a const. If it used to have a const value. What does that mean? What does that mean? Something like var foo equals const empty array, and then foo equals 1, 2, 3. Is that okay? Like then print foo. I don't care. Is this okay? Well, we are marking. Basically, we're marking the empty array as a constant, but it's okay. What if we did const bar equals this, and then bar equals 4, 5, 6? Yeah, now because all right, this is interesting. Bar, we can't change bar, right? Because the variable itself is constant, but in the case of foo, the variable is variable, but the value is constant. So there's a difference between these two, right? Okay. Constant variables can be assigned a value. There we go. This is basically the error for the bar. Okay. You can define constants that use type checks and casts, is and as, collection, if, and spread operators. There's also spread. That's nice. There's like an optional spread with the question mark. Nice. So let's see. There's a const object e equals 3 where I is a constant object with an integer value. Okay. I really want to play with this. This is okay, right? What if we do e equals 52? Is that allowed? No, because we mark the variable as constant, right? What if we did integer here instead of an object? That's also accepted because the integer is an object, right? And we also we can also infer the type as well. So why do we want to put object here? Because we also like we know what that's going to be. Const list, use a typecast. This is cool. All right, let's see. We're gonna bring back the object and we're gonna get the list now. So list is an array of I as integer, right? So if you click on the list right now, yeah, it's a list of integers. Sweet. Okay, there's a map. Map is like a dictionary, I guess, like an object in JavaScript. If I is integer, otherwise integer. Ooh, let's actually check this out. Where's the error? Okay, let me just like get this out. I need this to hide. There we go. We'll bring this back then. Okay, so the map, okay. If E is an integer, then we can use it as a key. And the value is a string. No. This is... What if we did this instead? What are we gonna get? Same thing, so I can even do doodles. It's gonna be the same, because it's a string. Nice one, yeah. They tried to like confuse us with the integer here, but it's actually a string. Right, so for example, we can do map of 0 equals to, I don't know. And this should be fine. It is perfectly fine, right? But if there's like an error, a warning right here. 23. Unnecessary type check. The result is always true. Yeah, because we set the value to 3. 3 is an integer. I is always going to be an integer. Yeah. They basically tell us this is okay if you do it, but you don't really need to do it. Yeah, it's an example, but what if we do this? What if we do integer string? Is this like another way? No. Okay, now we got type and type. We're gonna need to learn how we can... Yes. Gonna need to learn how we can actually create maps and define the type as well. But wait a minute, this is actually a value. This is not a type. Because we have the assignment operator. Alright, well, let's not get ahead of ourselves. Although a final object cannot be modified, its fields can be changed. In comparison, a constant object and its fields cannot be changed. They're immutable, right? So we have the user, right? I can do now user.name and change that to Riz. And it's perfectly fine, right? It's actually print this out, print user dot, actually it's just user dot greet. This should say hi Riz, even though we initialize it with Lazar. Ah, yeah, right. Now we have the edge. Oh, god damn it. Let's just remove this. We got the point. Exactly. There's another greet at the bottom. But if I were to make the user as a constant, then we should not be able to do this. There's an error. Let's see it. The constructor being called isn't a const constructor. Oh, it needs to have a const constructor. Try removing const from the constructor invocation. What? The const variable must be initialized with a constant value. Try changing the initializer to be a constant expression. What is that? Oh, got it. So this can be a variable, but this needs to be a constant. No. The constructor being called is in the const constructor. Try remove const from the constructor. Well, now you're messing with me. The following code produces a diagnostic because the constructor A isn't the const. Okay. Oh, there we go. We also need to do const on the constructor itself. Right, Reese, thanks for stopping by. Can't define a const constructor for a class with non-final fields. Man, this is too much. So now if we do the const, we also need to mark this as a final. I mean, it does make sense, you know. There we go. Now we cannot change the name. Yeah, because it's final. What if I don't mark this as a constant and do that again? Which is going to be... So it's the same, right? I don't understand. But okay. This is initialized by default. You know, properties of classes are lazy until you call them. Hello name. Okay, so if we just run this, it should function properly. Hello Lazar. Okay. I'm just like thinking about why would I put this and still do this to prevent the property from changing. Well, I can just do this and it's still gonna be the same. But maybe we'll find out. All right, let's see the types. We got an integer and double, string, boolean, a list or as an array, set, map, runes. Often replaced by the characters API. Okay, got it. Yeah, it's just a character, a rune. Yeah, that's pretty cool. And symbols. Okay. This support includes the ability to create objects using literals. For example, this is a string, it's a string literal, and true is a boolean itself, right? Because every variable in Dart refers to an object, an instance of a class. You can usually use constructors to initialize variables. Some of the built-in types have their own constructors. For example, you can use the map constructor to create a map. Some other types also have special roles. Object is the superclass of all Dart classes, except null. Null is not an object. Enum is the superclass of all enums. Future and stream is an asynchronous, are both asynchronous stuff. We'll check them out. Iterable, used in for loops and in synchronous generator functions. Okay, that's cool. Never, oh, there's also never, indicates that an expression can never successfully finish evaluating. Most often used for functions that always throw an exception. Nice. Dynamic indicates that you want to disable static checking. Usually you should use object or object optional instead. Okay, so that tells us something. And then a void indicates that a value is never used, often used as a return type. Yeah, void main, right? The object optional, null, and never classes have special roles in the class hierarchy as described in the top and bottom section of the Understanding Null Safety. Okay. We got numbers, integers, and doubles. We can also do hexadecimals, exponents. Okay. Here's a double. Double z equals to 1 is like 1.0. Okay. My cat is attacking me. Alright, so we can also parse. That's cool. var1 equals integer.parse 1 as a string.
And then one is going to equal to one string to double dot parse. That's awesome as well. Integer to string is, yeah, we're going to use this probably. And then a double to string, but that's also, there's also as fixed, which also, yeah, this is totally useful. Yeah, for example, we're going to be using this. Let me show you. We're going to be using this right here. We have these are basically the designs for the expense tracking app. Find any text layer component. All right, I got you. So these are, oh man, these are the designs, and as you can see, we use a lot of numbers. It's you know, it's an expense tracking app, right? So we are usually going to be handling decimals because the prices are not 32. It's like for just 32.99, which is basically 33, but they say 32, right? So yeah, we're gonna be using the toString as fixed because we don't want like a lot of decimal points because it's gonna break our UI. The integer type specifies the traditional bitwise shifts, complement, and or XOR operators, which are useful for manipulating and masking flags in bit fields. For example, 3 bitwise shift to the left of 1 point does that equal to 6? Let's see, we have the 3, here it is, 1 and 2 equals to 3. We're gonna shift all of them by 1 point. It's gonna be these, like the 1 will be here and the 2 will be 4. So 4 and 2 equals to 6. This is true. Okay, that's cool. That's cool. This is the OR. We have the 1 and 2 positions, then we have the 4 position as well. So this is 3 and 4, 7. Yeah. Literal numbers are compile time constants. Many arithmetic expressions are also compile time constants, as long as their operands are compile time constants that evaluate to numbers. What the? Got it. So we have a number that is a constant. We have a different number that's also a constant. If we try to basically do math with them, since both of them are constant, we can also name our third variable, like mark it as a constant, because these two are also constant. But I believe if we actually remove the const from one of them, we're gonna be in a pickle. Let's see. Sprint this thing out. Yeah, semicolon. There we go. But if I put this as a var, we should see a, yeah, we should have an issue. The ms per second, exactly, yeah. So that means this cannot be a constant. If we set this to var, it should be okay. Yeah, still gonna say 5,000. Yeah, but we can actually sneak up on it and make it 5001, and it should be okay as well, because it's variable, it's not a constant. All right. Strings. There are strings for single quotes, double quotes. You can escape it. You don't even need to escape it if you just switch the quotes. That has which is very handy. Dart has string interpolation, which is very handy. What is happening here? I don't understand this. So we define a variable as string interpolation. Dart has string interpolation. which is very handy, equals to... Oh, okay, so this is basically this. String interpolation, which is very handy. Okay, yeah. This was, yeah. Okay, and of course, we can also do capitals. Test whether two objects are equivalent. Two strings are equivalent, okay? You know what, let's just like jump through. Oh, this is nice. You can create multi-line strings with the triple quotes. This is also a multi-line string, of course, because this and this, Dart has no, it doesn't see them as different. A raw string by prefixing it as a runes and grapheme clusters for details on how to express Unicode characters in a string. Whoa, so basically this is a raw string. If we printed it out, because it has a /n, we should see two lines. Raw string, not even n gets special treatment, of course, because we didn't even read it. But if I actually remove that and run this, we should see two lines. There we go. In a raw string, not even the new line gets special treatment. Yeah. Okay, that's good to know. Literal strings, compile time constants. These do not work in a const string. Booleans, lists. Okay, let's see some arrays instead. This is an array. This is an array. Okay, we can index. This is a constant. Spread operator and null-aware spread operator. Okay, which provide a concise way to insert multiple values into a collection. Okay, so what does that mean? Let's play with something. Let's do this. We're gonna create a new array. 1, 2, null, 3. Non-nulls. We're gonna do optional array. Is this the syntax? The receiver can be null, so the null-aware operator is not unnecessary. Try replacing it with an ordinary spread. Let's print the array first and also print the non-nulls. Let's see what we get. Okay, so I misunderstood. Null-aware spread operator. If the expression to the right of the spread operator might be null. Oh, okay, you can avoid exceptions by using a null-aware. Yeah, got it. So it's not about the elements. It's about the whole array, basically, right? So if we did a list of integers, but that could be like an optional, right? And if we say if 3 equals to 5, then the array is gonna be 1, 2, 3. Because this is an optional, we can add the null-aware spread operator, and now the non-nulls will be an empty array. Here we go. The array is null because 3 never equals to 5, right? But the non-nulls is actually initialized. It's just, you know, the spread doesn't even happen because the array is null, so it's like initializing an empty array. That's pretty much it. Okay, that's cool. That's cool. Would have been cooler if we could have used this to like filter out all of the elements that are nullish. That are actually null. For more details, spread operator proposal. Dart also offers collection if and collection for. Let's check this out, which you can use to build collections using conditionals, ifs, conditionals, and repetition. Here is an example of using collection if to create a list with 3 or 4 items in it. The navigation bar has the home, furniture, plants, and if the promo is active, also get the outlets. Nice. There's also
Oh, there's also a collection for to manipulate the items of a list before adding them to another list. Cool. Let's. This is pretty cool. I gotta say. We're gonna print now right here. Let's say promo active is false. Home furniture plans. Outlet. Nice, nice. And we can also do, I don't know, footer, and we can say logo, company, and then we'll just drop a bunch of numbers for no reason. Var E in list of integers, right? 1, 2, 3, list of ints, and then we do a space, and then we provide the actual $I. What is that? We actually do this, right? It's not a string, but still. What if we just wanted to add these as like, if I add this as a string, it's gonna be a string. Well, okay, of course, we got them previously as strings. So if I print footer now, logo company 1, 2, 3, there we go. All right, that's cool. For more details, check out the control flow collection proposal. Nice. Collections, let's just see immediately. Empty list of strings. Is empty, is true. Apples and oranges, we can add all. Basically like add a different array into this array. There's index off. Then we can use remove, add, clear, beautiful. List.filled with 99 broccolis. You can also create a list using one of the constructors. So every element is a broccoli. Nice. Okay. There we go. We can do sets now. A set in Dart is an unordered collection of unique items. Dart support for sets is provided by set literals and the set type. Here is a simple Dart set created using a set literal. Halogens equals to a set. Dart infers that halogens has a type set of string, so we don't need to, okay? If you try to add the wrong type of value to the set, the analyzer will all runtime raises an error. Alright, let's actually try that. Halogens equals to, I don't know, 1, 2, and then 3. Print halogens. Is that gonna be a runtime error? No, actually. It's an object. For more information, type inference. So basically, Dart got the type of the first element. It's a string. The second, it's a string. The third one, it's a number. It's an integer. Do they have anything in common? Yes. They're both an object. So let's just mark halogens, I don't know how to pronounce this, as a set of objects. Okay. To create an empty set, use the, there we go, a target argument or assign to a variable of type. So we can either do var names equals a type string and then an empty curly braces, or we can do a set of string names equals to this empty. Yeah. Because if we do this, it creates a map, not a set. Okay, that's cool. That's cool. Because map literals came first. This is the default of map. So yeah, the Dart designers, they designed the map type first, so that's why empty, like a square braces, default to the map type. Then they actually developed the set, so this was already taken. If you forget the type annotation on this, Dart creates an object of type map dynamic. Okay, that's good to know. Add items to an existing set using the add and add all. So we got an elements, add fluorine and add all of the halogens. Okay, never mind. Use the length to get the number of items. To create a set that's compile time constant, we can just do const. Yeah. There's also the spread. There are the maps. Key values. Okay, the key can be anything, the value can be anything. Got it. Runes. Alright, let's see this. The laughing emoji. Yeah, we can basically use runes to express Unicode points. So, runes. Oh, there's a package. Okay. But I bet it's the dot characters extension that happens, you know, that's applied to a string. Yeah. Okay. Symbols. A symbol object represents an operator or identifier declared in a Dart program. You might never need to use symbols, but they're invaluable for APIs that refer to identifiers by name. Because minification changes identifier names but not identifier symbols. To get the symbol for an identifier, use a symbol literal, which is just a hashtag, followed by the identifier, radix and bar. Symbol literals are compile time constants. Okay, there we have the functions. That's cool. Even if we omit the type, it's still going to work because this compiles to a boolean. Is it null or is it not? So we can also get away without even providing the type. That's also cool. One expression, arrow. Nice. Is shorthand for return, yeah. Sometimes referred to as arrow syntax. Only an expression, not a statement, can appear between the arrow and the semicolon. Okay. If you put an if, you can't put an if, but you can use a conditional expression, like a ternary. Okay. Parameters. A function can have any number of required positional parameters. These can be followed either by named parameters or by optional positional parameters. Okay, we gotta see this. Named parameters are optional unless they're explicitly marked as required. When defining a function, use this to specify named parameters. So we had a function right here previously. Let's just get rid of this. We're gonna return a string, get name, for example, get greeting, right? And we're gonna return, you know what? We're gonna use an arrow. Hello, and then we'll do something else here, but then we can do this basically, right? So that's like name is a string. What? I don't know. I mixed it up. But if I create this, if I mark it as a required,
Okay. So then I can do this basically. Let me just remove this. Print get greeting, and now get greeting. Okay, name equals. Now we're talking. Now we're talking. Sweet. Okay, because if I didn't do this, if I just did this, we can have this. So I have to like provide it as the first argument. Now in this case, for example, when we don't have a lot of arguments in this function, it's not an issue, right? But if you were to build, I don't know, a function like add payment, I don't know, that also took like, I don't know, customer name, and also took the amount. What else do we have? We have an array, for example, of products, currency, date, right, store number, country, I don't know. Yeah, things can get like complicated. And if you call this, if you don't name your variables accordingly, you're gonna have a problem. But if that was a named parameter, you would say customer name and then equals to, I don't know, customer someone, right? But you will know that that actually maps to the customer name inside. Okay, yeah, it's a named argument. That's cool. Okay. When calling a function, you can specify named using the parameter name and then the value. Although it often makes sense to place positional arguments first, named arguments can be placed anywhere in the argument lists when it suits your API. Exactly. So for example, if let's actually try this. Let's make some function. Let's make some function that has a name first, it has an age, but then there's like what else? Address and city. I don't know, zip, it's not an actual integer, there are zip codes with strings, right? So we can return something. Oh yeah, we need to define or like make them optional as well. Yeah. So we can do name, age, address, city, and zip. Okay. What I'm planning on checking is this. I can provide the address. This is my address. I can provide the age. Actually, no age. First has to be the name. Then it has to be, I don't know, the age. And then I can do city. Right? It should be fine. And then the zip. Yeah. Yeah, so I pushed the address at the top, but these have to be in order, because if I switch these, then it's probably gonna complain. Let's see. Complaints. Because these are positioned arguments and these are named arguments. If the arguments are positioned, then you gotta pay attention to the position, right? It's in the name. Sweet. I like this. Although name parameters are a kind of optional parameters, you can annotate them with the required. Right? So for example, if I get rid of the city right now, it's not gonna be an issue because the city isn't optional, right? There we go. Null. What if I do required city? Complaints. So now we have to provide a city. No more complaints. There we go. Okay. If someone tries to create a scroll bar without specifying the child argument, then the analyzer reports an issue. Sweet. Optional positional parameters. Wrapping a set of function parameters in square brackets marks them as optional positional parameters. Dude, okay. From message and device. From says message. If there is also a device, then we have the result with a device. Okay. Bob says howdy. Bob says howdy with smoke signal. But why do we need to like add these, you know? Why do we need to add these? There we go. Nothing, no errors. But what if we remove this? What happens? QBT, thanks for the follow. Appreciate it. What do we get now? 3 positional arguments expected, but 2 found. Yeah, this turns out this is not how you defined a positional optional. Why though? It's perfectly fine. But okay, you know, if they say so, we'll just respect that, right? Okay. I believe this is gonna trip me a lot in future. But we'll try to remember. Yeah, this is how we define positions optional characters. So characters arguments. Yeah. Default values equals to something else. These are named ones. And these are the positional with a default. You can also pass lists, etc. Okay, so do stuff. Wow. We define a list. We define a map. What is this? Wait a minute. Okay. Let me see. Let me dissect this. Do stuff. Do stuff. Right? So these are both named variables. And because they're named variables, by default, they are going to be optional. Unless we make them required, right? And these are the... Yeah. These are the default values. So if I just play, list will be just 1, 2, 3, and the gifts will be paper, cotton, leather. Yeah. But if we did list is actually 10, 11, 12, we're gonna see that, yeah, we're gonna see that reflect. Okay, that's cool. The main function is where everything begins. This is the Big Bang. Here's an example of the main function with arguments for common command line app. Nice. Darts, we got arguments.dart 1 tests. You can use the args library to define and parse command line arguments. Okay, there's a library as well if we want to do CLI. Functions as first class objects. Yeah. We have a print element that accepts an integer as an argument and it prints it out. So we can do for each and then pass the function. That's awesome. You can also assign a function to a variable. To something like this. Ah, yeah, got it. var loudify equals an anonymous array function that accepts a message and it prints it out. What is the type of the message though? How does it know? How does it know that the message is gonna be a... Oh, okay, it's a dynamic. But what if we did Cloudify 13? Oh. I forgot how to type. Yeah. To uppercase is not a function because we have a number, you can't lowercase a number. But if we did this, then this is gonna blow up. But now it's chill. So there we go. Okay, don't do that. We should not do that. Always get the actual type in there. Anonymous functions. Okay. Lambda or closure. There we go. This is an anonymous function, right? For each. And this is where the function starts. We get the arguments and this is the function body. Click to run to execute the code. Apples. 0 apples, 1 bananas. Yeah. 0 apples, 1 bananas, 2 oranges. Okay. Yes, we can actually arrow that. There is also nested functions. Notice how a nested function can use variables from every level all the way up to the top. Here's the top level, inside main, inside function, but inside of the nested function we can access all of them. Okay. Okay. Getting bored. Let's try to do... We got like 20 minutes, yeah. Oh, okay, now we got some type tests. As is and is. True if the object doesn't have the specified type. Okay, employee is a person. Okay, this is casting. This is checking. Employee is a person, then the first name is Bob. Okay. These are cool, but I've never actually used... I know there's like some of these in JavaScript, TypeScript, I can't even remember. Does anyone like use these? Like assign... If B is null, otherwise B stays the same. Like these type of operators. I've seen some people use them. Of course, these are definitely used, but not like these. Like I never use this. Okay. Yeah, let's actually try doing like, let's try the hacker rank. Was it this? Like, where are the actual... Was this the thing with the actual... No. What was the... Can you guys tell me like what was the website where these like challenges were? Lead code. Lead code, there we go. Do I have to? Oh. Let's log in then. There we go. Give me a problem. We're gonna start small. Let's check out the two-sum. Boom, 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 boom. We're not actually gonna write. Is there Dart in this? Yeah, okay. We're gonna write here then.
Given an array of integer, return indices of the two numbers such as they add up to target. You must assume that each input would have exactly one solution, and you may not use the same element twice. We can return the answer in any order. So the numbers are 2, 7, 11, and 15. The target is 9. The output is 0 and 1. Why? Because 2 and 7, yeah, equals to 9, so we return 2 and 1. 2, 3, 4, the target is 6, then it should be this thing, 1 and 2. And we can assume that each input would have exactly one solution, okay? You may not use the same element twice. To sum, okay? If we have 3 and 3, there we go. These are the constraints, only one valid answer exists. Okay, this is the solution. Let's bring it here actually. Wait, we need the main actually too. So we can execute. To sum. It needs to return two integers. These are the numbers, this is the target, right? So we can do, let's keep, I don't know, the first index. We'll set this to, I don't know, -1, and then the second index we'll set this to -1 as well, and then we'll return an first index, second index, like so. Okay. Now we should probably loop through these. Let's see. E is 0, E is less than nums.count, no length. Right, so for example, we are looking for the first and second index of these two. This should be like a nested for. Yeah, I'm gonna just basically do this in the most stupid way possible. I just wanna see if I can actually, no, it's like e plus 1 is not less than, this is less than this, j is gonna go up, this is -1, there we go. Right, so we have e starting from 0 and j starting from the 1 next to it, and we can do if e plus j, I don't know, if nums of e plus nums of j equals to the target, then what we don't want to do, first index is e, second index is j, and then break. Is there a break thing in Dart? It should be. We want to stop when we're here, then we want to return this. So let's see if this is the input. Print to sum. This is the first, the target is 9. The output should be 0 and 1. 2 plus 7 equals to 9. 0 and 1. What if we change this to be like 7 and 15? Let's set it to 22, the target. We should get 1 and 3. Okay. Okay. Yeah, I guess this is... Yes, this is nice. It didn't feel like I need to... For example, we got the break, which is pretty much a muscle memory. Like after a while, the way we wrote the fors were very, very, you know, intuitive, just like any other languages. The way we returned like an anonymous immediate array with just 2 elements, that also feels natural. Yeah, I wasn't even thinking about Dart. We can even like get rid of this, and now the to sum will return Oh, it's a dynamic now. Okay. Okay. But yeah, it didn't actually feel like I'm thinking, like I didn't even think that I'm actually doing the Dart. I'm writing in Dart, you know. It just feels so natural. I like this. I like this. Wait until you see when we get into Flutter. I believe there's gonna be a lot of, you know, unknown stuff, a lot of, you know, headaches. But yeah, so far so good. I actually like Dart. Cascades allow you to make a sequence of operations on the same object. Nice. In addition to accessing instance members, you can also call instance methods on the same object. This often saves you the step of creating a temporary variable and allows you to write more fluid code. Check out the following code. We have a paint, so we call the constructor. Then we set the color to colors.black. We set the stroke cap to stroke cap.round. And then we set the stroke width to 5.0. And then we close the actual statement, or basically this is a whole cascade. So the constructor returns a paint object. The code that follows the cascade notation operates on this object, ignoring any values that might be returned. So this is an equals, right? Colors.black. I'm not sure if we can. Let's actually test. Let's actually test that. Let's say a equals. No, let's do a equals 0. B equals 1. We'll do A equals B equals 2, and then let's print these out. Yeah, we actually wanna... Is this gonna be 2 and 2? Yeah, because the equals operator returns the value. So it's gonna be right to left. The number 2 is gonna be assigned to the B variable, but it's gonna be the return value of, you know, as an expression, is gonna be the return value will be number 2, and then we'll take that and actually put it into the variable A as well. So these are 2 and 2. Okay, cool. Because if we didn't do this, we can't have the cascade, right? But if we try to get the result out of this, you know, this is going to be the return value, or like the result of this is going to be colors.black, whatever colors.black is. If it's a string or if it's a different type, I don't know, but that's going to be the result. But doing the cascade after using the constructor basically tells us that regardless of what has been returned right here, I'm gonna keep my eye on the first thing, on like the last thing that has been returned before we actually use the cascade operator. And that was the return type of paint, which was, you know, the paint object itself. So that's how we can do paint.color equals, and then paint.stroke cap equals, and paint.stroke width equals. But this is all, yeah, it does look good. The code that follows the cascade notation operates on this object, ignoring any values that might be returned. Yeah, this is the equivalent, basically. Check it out. Paint.color equals this. Paint.stroke cap equals that. Paint.stroke width equals that over there. Yeah, much cleaner, because we don't have to repeat paint. I like this. I'm not sure if I'll ever gonna get used to it, but I actually like this. There's also, if the object that the cascade operates on can be null, then use a null shorting cascade for the first operation. Okay. None of the cascade operations are attempted on that null object. Yeah, so
Only on the first one we can add the question mark, right? The null shorting cascade. If query selector doesn't return us the element with the ID confirm, then none of this is gonna happen. If it does, then we'll set the text to confirm, we'll add the important class, we'll register the onClick event, and then we'll scroll that into the view. Nice! This is actually cool. This is actually, and this is, of course, this is the equivalent. We get the button with the ID of confirm. If that exists, like set this, but this is much cleaner. Much cleaner. I like it. I actually haven't seen this in like any other programming language, and I actually really love this. You can also nest cascades. Check it out. Like, things get crazy real fast. Create an instance of the address book builder. Set the name, the email, the phone. But then also the phone is an object, like it's not a number or anything else, string. It's an actual phone number builder. And then do these things as well. Do the build and then do the build on the address book builder. Awesome. Be careful to construct your cascade on a function that returns an actual object. For example, the following code fails. Yeah. Exactly. Because we don't have a cascade here, right? sb.write is a void function. If we cascade on that, we're basically executing write method. We're calling the write method on something that is void, that it doesn't even have the write method, right? Got it. You can construct a cascade on void, yeah. Exactly. But I wonder if we can call this and then do .write. That should be available, that should be possible, because with the cascade we're basically cascading on the build buffer. So we'll write foobar and then sb dot, how do we get this out now? To string? Yeah. Print. Should be foobar. We should get foobar. There we go. Yeah. Yeah, but if we did like this now, we are cascading on something that returns nothing. We can't really do that. Nice! Cascade. Function application represents a function call. Okay, conditional subscript access. So is that like I don't know, array 1 2 or like 0 1 and 2, and basically print out the 5th element, right? Or sorry, the 6th in this case. It's a warning, it's still gonna... Oh, okay. Did I actually do that right? But the leftmost operand can be null. Oh, okay, this can be null. Sorry about that. Yeah, that can be null. So it's like a list of integers. You know? Array. And then we can do this. We'll mark it late. So we do, is that the... It's definitely unassigned at this point. Or it doesn't matter. But yeah, if it's null and it's gonna try to access the 5th element. Member access, conditional member access, null assertion operator. Yeah, it's gonna break. If foo is null, then you try to access bar, it's gonna break. Cast an expression to its underlying non-nullable type, throwing a runtime exception. Yeah, if the cast fails. Let's see a switch. clean, clean, breaks and continues, whiles and do whiles. That's it, you know, it's, yeah. I like Dart. I actually like Dart. Because it's, yeah, I don't have to learn a lot of things to know Dart. You know, you can see, you know, there we go. Try, and instead of catching, this is on. Oh, wait a minute. There's actually a catch, right? But this is a specific catch. Yeah. So, if you call the breed more llamas function, it actually crashes. If it crashes on out of llamas exception, then it's gonna get in here. If anything else that is an exception, do this. But if no specified type, or like the exception is something, I don't know what, print something really unknown. Yeah. Got it. We can also get the stacked trace as the second argument. Sweet. Okay. So check this out. We have a misbehave function that has a try and catch, but it actually can rethrow. Allows the callers to see the exception. Yeah, this is also cool. Rethrow. And then finally, as well, do in all cases, nevertheless, clean the llama stalls. Okay. Okay. Super. Yeah, we can call super to access the from JSON method that's defined inside of the person class. Fetch default data, right? Are we gonna see some codes? Where is it? In person, in employee, instance of employee. Alright, so we say, let's say we have the vector 2D, two final variables x and y, and this is the constructor. Now we have a vector 3D that extends the 2D. It also adds a third double final variable called z. And when we actually call this constructor, we want to do super x, super y, so it actually accesses this this constructor, and then this .z to actually set the third variable inside of its inside of the class. All right, that's all right. Super initializer parameters cannot be positional if the super constructor invocation already has positional arguments, but they can always be named. Require this x and require this y. Okay, we'll check this out maybe later when we actually need this. Okay. Ooh, it's getting late. We'll check this out later. I guess it's okay for today. The results is that I actually like Dart. It seems like a familiar language. I don't feel yeah, I actually feel comfortable trying out Dart, which honestly this was my first time. Like, I'm not even kidding, this was my first time. And as you can see, there's like a lot of, you know, a lot of influence and inspiration from the more familiar languages, like Java is here, you know, and probably JavaScript and things like that. So I actually like it. We'll see how the module system, or like the package system, works in Dart, so we can create, you know, our own packages and reuse those packages throughout our apps or modules, etc., etc. So we'll check that out. We'll see more in terms of classes and inheritance and all these things. And I believe we can like start thinking about like getting into Flutter and actually start with the app. So I'm gonna go now. I hope everyone had fun. I hope this was a good episode for you and actually learned something. And I'll see you on Tuesday. Same time, it's just gonna be Tuesday. Alright, take care everyone and have a good weekend. Bye bye.